Artificial intelligence, or AI, is not a brand new concept in military thinking. Its roots stretch back further than many might imagine. Early explorations began decades ago, focusing on rule-based systems. These were simpler forms of AI. They could help with tasks like data analysis or simulating war games. The aim was to process information faster than humans could. This could give a strategic advantage. Early AI was more about assisting human decision-makers. It was not about machines making decisions on their own. The technology was limited, but the ambition was clear: to harness computational power for defense. This set the stage for future, more complex developments. Over time, AI in military applications evolved significantly. We moved from basic algorithms to more sophisticated machine learning. This meant computers could learn from data. They could identify patterns and improve their performance without explicit reprogramming for every new scenario. This advancement opened up new possibilities. Think of improved target recognition systems or more efficient logistics and planning tools. The focus shifted from simple automation to creating systems with a degree of understanding. This understanding, however, is still based on the data they are fed. The journey has been one of steady progress, with each step building upon the last, leading us towards today's more autonomous systems. So what exactly do we mean by an autonomous weapon? An autonomous weapon system, often referred to as an AWS, is a type of military robot. It is designed to search for, identify, target, and potentially neutralize enemy combatants or targets. Crucially, it can do this without direct human control at the moment of engagement. This human out-of-the-loop capability is what distinguishes it from remotely piloted drones, where a human operator is still making the final call. The level of autonomy can vary. Some systems might only be autonomous in certain functions, while others could operate with near-complete independence once activated. This definition is vital for understanding the discussions that follow. How do these advanced weapons actually work? They typically rely on a combination of sophisticated technologies. Sensors, such as cameras, radar, and LiDAR, gather information about the environment. This data is then processed by powerful onboard AI algorithms. These algorithms analyze the sensory input to detect and classify potential targets. They might compare what they see to vast databases of known objects or threats. Based on this analysis and its pre-programmed rules of engagement, the system then decides on a course of action. This could involve tracking a target, firing a weapon, or deciding not to engage. The speed of this process can be incredibly fast, far exceeding human reaction times. The introduction of AI is fundamentally reshaping the landscape of modern warfare. It is changing how battles are fought and how strategies are conceived. AI offers the potential for significantly faster decision-making cycles. This is often called the OODA loop: observe, orient, decide, act. Machines can process vast amounts of information from diverse sources almost instantaneously. This allows for a speed and scale of operations previously unimaginable. Swarms of AI-controlled drones, for example, could overwhelm traditional defenses. Cyber warfare, too, is increasingly driven by AI, both for attack and defense. This shift pressures military forces worldwide to adapt or risk being left behind in this technological race. We are already seeing examples of AI-driven systems being developed and, in some cases, deployed. Autonomous drones are perhaps the most well-known. These can perform surveillance, reconnaissance, and even strike missions. Some systems are designed to operate in groups, coordinating their actions. Beyond aerial systems, AI is being integrated into ground vehicles and naval vessels. It is also crucial in intelligence analysis, sifting through enormous datasets to find actionable information. Missile defense systems increasingly use AI to detect and intercept threats with greater speed and accuracy. These are not science fiction. They are the tangible results of ongoing research and development programs across the globe, marking a clear trend. From a purely military standpoint, the advantages of autonomous weapons can seem compelling. One of the most frequently cited benefits is the potential to reduce risk to human soldiers. Sending machines into dangerous situations means fewer human lives are put in harm's way. AI systems can also operate in environments too hazardous for humans, such as areas contaminated by chemical or biological agents. Proponents also argue for increased precision, suggesting AI could lead to fewer civilian casualties if programmed correctly. They can operate tirelessly 24/7 without fatigue affecting their performance. These perceived benefits are strong drivers for their continued development by military powers. However, there are significant disadvantages and inherent dangers to consider. The increasing reliance on complex AI systems introduces new vulnerabilities. These systems can be susceptible to hacking, spoofing, or electronic warfare, potentially turning them against their creators or causing unintended actions. There is also the risk of an algorithmic arms race, where nations compete to develop ever more powerful AI weapons, leading to instability. Furthermore, the behavior of complex AI systems can sometimes be unpredictable, especially in novel situations not covered by their training data. This unpredictability, when combined with lethal force, presents a serious concern for military planners and ethicists alike. The core ethical dilemma surrounding autonomous weapons revolves around a fundamental question. Is it morally acceptable for a machine to make the decision to take a human life? Many argue that such a critical decision must always involve human judgment and moral reasoning. A machine, no matter how sophisticated its algorithms, lacks genuine understanding, empathy, and the capacity for nuanced, ethical deliberation. It operates based on code and data, not on a moral compass or a comprehension of the value of human life. Delegating lethal authority to an algorithm raises profound questions about our own humanity and the kind of world we wish to create for future generations. This is perhaps the most debated aspect. Another deeply troubling issue is that of accountability. If an autonomous weapon makes a mistake, resulting in unlawful killings or collateral damage, who is responsible? Is it the programmer who wrote the code? Is it the manufacturer who built the machine? Or is it the military commander who deployed the system? The chain of responsibility becomes blurred when no single human directly makes the kill decision. This accountability gap is a serious challenge for international law and military ethics. Without clear lines of responsibility, there is a risk that such incidents could occur without anyone being held properly accountable, undermining justice and the rule of law in armed conflict. Furthermore, the potential for bias in AI algorithms is a significant concern. AI systems learn from the data they are fed. If this data reflects existing human biases, whether conscious or unconscious, the AI will inevitably perpetuate and even amplify these biases. This could lead to autonomous weapons disproportionately targeting certain groups of people based on ethnicity, religion, or other characteristics. Ensuring fairness and non-discrimination in systems that wield lethal power is an incredibly difficult challenge. The consequences of biased algorithms in warfare could be catastrophic, leading to tragic and unjust outcomes on the battlefield and further fueling conflict. The debate often centers on the level of human control. Three main concepts are discussed: human in the loop, human on the loop, and human out of the loop. Human in the loop means a human makes all critical decisions, especially the final decision to use force. Human on the loop implies the machine can carry out tasks autonomously, but a human supervises and can intervene if necessary. Human out of the loop describes fully autonomous systems that can select and engage targets without any human intervention after activation. Many organizations and ethicists argue for maintaining meaningful human control, insisting that a human must always be in the loop for lethal decisions. Different nations are adopting AI in their militaries at varying paces and with diverse philosophies. Major military powers like the United States, China, and Russia are investing heavily in AI research and development for defense purposes. They see AI as a transformative technology that could confer a decisive military advantage. The United States has focused on AI for enhancing existing systems and developing new autonomous capabilities, while officially stressing the importance of ethical guidelines. China has declared its ambition to become a world leader in AI by 2030, with military applications being a key component. Russia is also actively pursuing AI for weapon systems, recognizing its strategic importance. This global pursuit of AI-powered military technology inevitably raises the specter of a new arms race. As nations compete to develop more sophisticated autonomous weapons, there is a risk of escalating tensions and increasing global instability. An AI arms race could be particularly dangerous because the technology is evolving so rapidly. It might also lower the threshold for conflict, as nations might be more willing to deploy autonomous systems than human soldiers. The potential for rapid automated escalation, where machines react to other machines at speeds beyond human comprehension or control, is a deeply worrying prospect. This race could lead to a future where conflicts are fought predominantly by machines, with unpredictable consequences. In response to these concerns, there are ongoing discussions about the need for international treaties and regulations governing autonomous weapons. Groups like the Campaign to Stop Killer Robots advocate for a preemptive ban on fully autonomous weapons. United Nations forums have hosted numerous meetings where states discuss the legal, ethical, and security implications. However, achieving consensus is proving difficult. Some nations are reluctant to impose restrictions that might hinder their technological development or perceived security interests. Defining what constitutes meaningful human control is also a complex challenge. Despite these hurdles, the dialogue continues, reflecting a growing global awareness of the risks involved. Looking to the future, the integration of AI into warfare seems inevitable. The technology offers too many potential advantages for military establishments to ignore. However, this power comes with profound responsibilities. The key will be to guide its development and deployment wisely, prioritizing human control, accountability, and adherence to international humanitarian law. We stand at a crossroads. We can choose a future where AI leads to more unstable and inhumane forms of conflict, or we can work collectively to establish robust, ethical, and legal frameworks. This will ensure that human beings remain in ultimate control of the use of force, safeguarding our shared values, even as technology advances relentlessly. The date today is May 30th,